Mr. M presents Area of Triangles. Hi everybody. In this video we're going to take a look at how to find the area of a triangle. But first, let's look at this rectangle. Weird, right? I know. Stay with me. Most of us by now are pretty comfortable finding the area of a rectangle. We know that the area of a rectangle is length times width, and that equals our area, squared units of course. And if we wanted to find the area of this rectangle right here, we would simply do 7 centimeters multiplied by 5 centimeters, and that would equal 35 centimeters squared. Okay, easy, right? Now I'm going to throw a bit of a monkey wrench into the situation. What's going to happen when I take this line and divide my rectangle neatly in half this way? What have I created? You should be able to tell that I've created two triangles. One here and one here. Now these triangles are literally cutting the rectangle in half, and that means that each of the triangles is literally half of that rectangle shape. Which means that if I wanted to find the area of these triangles, all I would have to do is take my original area, which was 35 square centimeters, and divide it by 2. So my area for this particular shape would be 17.5 centimeters squared for each of these triangles. Now that's handy in this particular circumstance, but I'm not always going to have a rectangle to work with, so I'm going to have to figure out how can I find the area of a triangle when it's on its own. Let's take a look at another parallelogram and see if that will help us a bit. So let's test this with a different shape of parallelogram. Once again, I've got a parallelogram here, and by now we should know that a parallelogram is also a length times width shape for area, so L times W equals area squared, and in this case that means that 9 centimeters times 5 centimeters equals 45 centimeters squared. So that's great. And we've already done an experiment where we showed that if we divide a parallelogram in half, we get 2 completely equal triangles, which means that the area, 45 centimeters squared, divided by 2, here it is, divided by 2, equals the area of my triangle. And in this case, that's 22.5 centimeters squared. So basically what we're saying is area of a rectangle divided by 2 equals area of a triangle. Area of a rectangle divided by 2 equals area of a triangle. That's great if I already have the area of a rectangle, but like I said before, what happens when I'm working just from a triangle? So we just learned that the area of a rectangle divided by 2 gives me the area of a triangle. So what happens when I just have a triangle sitting by itself? Well, what I have to do is imagine what if it were a rectangle. So to get area of a rectangle, that equals length times width. I don't have the area of a rectangle here, but I do have a length and a width. The width is right here. It's 6 centimeters. Okay, that's the width of across this entire thing. Now how do I find the length, or the height as some people like to say? Well, I just have to draw a line from the base of my triangle to the top point of my triangle. Okay, and in this case it looks to be almost the same as my base. I'm going to just say it's 5 centimeters. So what I've done is I've found my length and my height, or my width of my triangle. So that equals 5 centimeters times 6 centimeters. And that would be great if I had a full rectangle, but remember what we said? The area of my triangle is the area of a rectangle divided by 2. So once I solve this, I then have to divide by 2. So that means that the area of this triangle is 5 centimeters times 6 centimeters, which is 30 centimeters squared divided by 2. So the area of this triangle equals 15 centimeters squared. Not bad, right? I used what I knew already about a rectangle, and I used that to find the area of this triangle. Now, sometimes finding the length and width, or base and height as we might say, for a triangle can be tricky depending on what measurements they've given us. Here they've given me 3 meters as a base, which is great, except it's very challenging for me to figure out what the height of this particular triangle is. So what I want to do is simply get my ruler and draw a nice straight line from the topmost point of my triangle. And I'm going to draw a line straighter than me because you'll have a ruler, and sort of form a right angled corner. And this line right here is going to be the height. Okay, so I'll have 3 meters as my base because that's where the triangle has a base. And right here, my height will be, and let's say, looking at it, I would say it's about 7 meters, that line right there. Obviously, I would measure it if I had a ruler using grid paper or some measurement or something like that. That means that this is my half of a rectangle, so my measurement is going to be, my area is going to be 3 meters times 7 meters, and then I'm going to divide that by 2 because it's only half of a rectangle, so I can't find the whole area of a rectangle. So that equals 21 meters squared divided by 2, which equals 10.5 meters squared. Okay, so here's a bit of a final test here. Let's see how you do. Here's a triangle with 3 measurements. There's a base, there's a height, and there's an extra measurement that you don't actually need to find the area of this triangle. So I'm going to ask you to use what you've got here, give it a try yourself, pause the video, and then come back and we'll solve it together. Okay, let's see how we did here. In this case, the base that I want to use is 11 centimeters. The reason I want to do that is because I've also been given a height. So when I have those 2 measurements, I want to take advantage. And in this case, that height is 6 centimeters. So I've got my base of 11, my height of 6. Now, in a different situation, the 7 centimeters here, could that be a base? You bet. But what I would want is I would want a height probably on this line that would also help me to find that area using that base. But since I don't have that, I'm going to go with my 11 and my 6. Now, what I'm going to do is I'm going to, once again, do the first part of this question as though I was finding the area of a rectangle. So, I'm going to solve 11 centimeters times 6 centimeters as though I was solving for the area of a rectangle. And of course, that's going to be 66 centimeters. But then I have to remember that a triangle is only 1/2 of a rectangle. So 66 centimeters divided by 2 is going to be my area of a rectangle, and that is, sorry, that was 66 centimeters squared, by the way, and that's going to be 33 centimeters squared. Okay, so that's going to be the area of this particular triangle. Okay, so before we're done, let's see if we can come up with a solid formula that we can use on a consistent basis to make our job a little easier and a little faster. As we say, mathematicians like to be efficient. We know that the area of a rectangle equals length times width. That's pretty safe. And we know that the area of a triangle equals the area of a rectangle, like we described, divided by 2. But of course, what's problematic is to get my area of a triangle, I'm not always going to have a full rectangle to use, because rarely am I going to look at a triangle and see that it is double as part of a rectangle. Usually it's going to be a triangle on its own in isolation. So instead of saying area of a rectangle divided by 2, let's use this part, which is the area of a rectangle, length times width, which I'm always going to be able to get whether it's in a rectangle or not. If it's just an isolated triangle, I can still find the length and the width, and then divide that by 2. So there are my 2 pieces. I'm going to use the area of a rectangle, which is length times width, and I'm going to remember that since it's a triangle, I need to divide by 2. So my formula for area of a triangle equals length and width, length times width, sorry, divided by 2. Now I can use that at any time with any triangle. Okay, good luck, guys.